All right, so first off, we should talk about the things that you're doing for homework tonight, just to make sure that you're on the right page there. Or that you're doing tonight, I should say, that we're going to look at tomorrow. So we've got our population genetics. Remember to get your choices in. All right. You know, that's where you write down, hand or left thumb over right thumb, or whichever one you're doing the dominant recessive. Okay, that's the first thing that you have to do. The second thing that you have to do is your game. Play the game of A versus B with the new scoring. And then the third thing you have to do is tell the points that you want for the game if you have A, B, and C. Okay? There is the extra credit thing that you can do. And the link, I'll send it to you. The link is worldmagazine.com/topic/gambling. I'll send that link to you so that you can do that if you want to. You don't have to. It's extra credit, so just do that if you want to. All right. So what I'm going to do, and then some of you may not have gotten your scatter plots done yet from last night, so get your scatter plots done. Where you have to write the equation y equals mx plus b. Choose one of the graphs that's not already done in that document and get that done. But that's only if you didn't do it last night. All right, we're going to go on today, and in our textbook, we're on page 636. Now, page 636 talks about probability distributions, and we've actually done a probability distribution, only we didn't talk about it that way, and that's when we were in empirical probability, and you guys did your chart for the dice. I'll just start with somebody's, I don't care. I'll do Luke's since he was the first one to do it. This is actually on page 636 of your textbook. Or 637 of your textbook down at the bottom. But here's how they figured it out. Okay, there's one way to get a 2. So it's 1 out of 36. To get a 3, there are 2 ways to get a 3. So that's 2 out of 36. There are 3 ways to get a 4. So that's 3 out of 36. There are 4 ways to get a 5. Oops. So that's 4 out of 36. There are 5 ways to get a 6. So that's 5 out of 36. To get a 7, there are 6 ways. To get an 8, there are 5 ways. To get a 9, there are 4 ways. To get a 10, there are 3 ways. To get an 11, there are 2 ways. And to get a 12, there are 1 way. So that's 1 out of 36. So if you see the chart on page 637, it shows you what the probability is, and if you notice the sum, the probability of 7 is the most common, and so on. Okay, so that's just probability distributions. Now, let's look at page 638, because you did one of these probability distributions in our population genetics lab. So I'm going to go to that. And let's see here, population genetics. And since you guys haven't done them all yet, I'll just choose one that people haven't done. Early myopia. Do we have that one as one of the choices? Let's see here. I don't see anybody doing that one. So let's do that one. Okay. Actually, we didn't have anybody doing a chew either, did we? So let's do a chew. All right, here's how it works then. We've got a chew. In a chew, there's a dominant, which is sneezing at light is dominant, I believe, right? Isn't that what we decided? Yeah, dominant is sneezing at light. So recessive would be no sneeze. So I'm going to use, we always base our letter on the recessive one. No sneeze is small letter N. Capital N is sneeze. Capital N is sneeze. Small letter N is no sneeze. We always start with the recessive trait and count how many recessives there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There were 13 out of 20 recessive NN. That means the other three sections, I'm going to use the highlighter, the other three sections here added up to 7 out of 20. So how do we figure that out? Well, here's the mathematics that you use to figure it out. If you take the square root of this number right here, that tells you the prevalence of this recessive gene. So let's take our calculator and let's take the square root of 13, backspace, fraction 13 out of 20. And we get square root of 65 over, I'm going to write over 100. Okay, so if that's the square root of 65 over 100 there, it's the square root of 65 over 100 here. Now you guys are used to dealing with decimals, so I'm going to change that to a decimal. So the recessive trait, and I'm going to use blue here, the recessive trait is 0.80, I think that was a 6, right? 806. These two genes, N and N, have to add up to 100%, so this would be 0.9 or 194. I'll do that math on the calculator. 1 minus our answer is 0.194. So the dominant trait is 0.194. So then we can figure out the other numbers. This box here is 0.194 times 0.194. So we're going to take that answer and square it. 0.194 times 0.194 is what was that? 0.038. Then you take this box here will be 0.806 times 0.194. So this is 0.156, and this is 0.156. And if you add all four of these up, you will get all the different choices. Let's go to the next one. Let's see if we can choose another set of numbers here. Did anybody do bent little finger? I can't tell. Let's just pretend that the only bent little finger we have is this one right here. Okay, so recessive, we have 1, 2, 3, 4, 5, 6, 7, 8. So now when we make our chart, we're going to have the dominant is bent in, so bent finger. The dominant is bent in, so the recessive is small letter s, capital letter S is dominant. Capital S is bent. Okay. We had, now I forgot what number that was. 8? 1, 2, 3, 4, 5, 6, 7, 8. We had 8 out of 20 were in that box down there. So if we take the square root of 8 out of 20, which is 0.632. So if that's 0.632, 1 minus that is 0.368. Okay, so now we can fill in the other boxes. Oops, I forgot to write in the other numbers. So this is 0.368, and this is 0.632. Okay, we can fill in the other boxes. 0.368 squared is 0.135. 0.632 times 0.368. 0.632 times I forgot what number it was. 368 is 0.233. So all four of these, oops, I'm going to change colors. All four of these add up to 100%, or one whole, all of the different choices. So that's how you do that chart on page 638. So what I would like you to do is try one of the other ones that I didn't do, like do the dimples or something like that, and see if you can figure out what the proportion of the population that has that particular gene is. Let's see, what else do we have to do? Make probability distributions. If you notice the one that's on page 637, they give us a probability distribution of the contact between children and elderly who live alone. Okay, so those that have 7 times per week is 680. Those that have 2 to 6 times per week is 276. Those that have 1 time per week is 236. And less than 1 is 199. And the total number of people is 1391. So the probability of having 7 is 680 over 1391. The probability of 2 to 6 is 276 over 1391. The probability of 1 is 236 over 1391, and so on. Okay? Now, what's kind of interesting is that you can use this to figure out what the average number of contacts is. And the way you do that is you take the probability times this number, okay, and add those together. Probability of 0 is 199 out of 1391. Now, since this says 2 to 6, let's just say the average is 4. Okay, so on our calculator, to find out how much contact the average person had, we would just take 7 times fraction 680 over 1391 plus 4 times fraction 276 over 1391 plus 1 times fraction 236 over 1391. But I'm not going to do the last one because 0 times anything is 0, so I'm just going that's going to be adding 0 to it. So the average number of visits per person per week or whatever, per week is 4.38. So that's what we're going to be doing for Friday. But for today, I think you have enough stuff that you can do a probability distribution for your, not theoretical probability, but you can do a probability distribution for your dice tossing. I'm going to put in 6 rows here for you to do it. 1, 2, 3, 4, 5, 6. Insert rows above. Okay? So the number 1, 2, 3, 4, 5, 6. So I'm going to choose Jack's numbers here. How many? Now, what's interesting is you can let Excel do, or your sharing program do the counting. So equals, count if. So we want to count the number of times in this column count if the number of times out of 50, comma, he had a 1. Okay? And now what's interesting is we can drag that down, and we have to change the numbers because it's actually going to start at 13 to 62, and we want to count the number of 2s. And then we go 13 to 62, and we count the number of 3s. And 13 to 62, and we want to count the number of 4s. And 13 to 62, we want to count the number of 5s. And 13 to 62, we want to count the number of 6s. If you notice, Jack had more 5s and 6s than we would expect. And I would like you to notice that he already knew that, because do you see how his average was 3.65? If you remember, we thought the average should be 3.5. But because he had more 4, 5s, and 6s, that's why his average was a little bit bigger. So what you can do with this is you can just copy Jack's information and paste it for your column, and it'll calculate how many you have. I don't know why it says that I have a 2, a 3 and a 4. Where is it getting the 2 from? 13 to 62. Where is the 2? It's saying that I have a... Oh, I made a mistake. This is supposed to say 2 here. There we go. 2. Now it's right. Okay, so I did have Jack's wrong. He had, let's make sure. That's his 1s, his 2s, his 3s, his 4s, his 5s, and his 6s. So his most common number that he had was 2. Anyway, that's what you have to do for today. And if you have any questions, you can call me, okay? Or drop me an email.